Yes. So yeah, just disclaimer, everything we do it for educational purpose, ethical use only, no illegal activities, nothing. Yeah, so we can try web application security. So first, in order to understand the security of web application, you should know what web application is. So first, let me give you a quick idea what web application is. So for example, you go visit a particular website. Let's say I go visit a google.com. So this is just a website, google.com. And s- s- so this website, I opened it on my browser. We call this something called client, like client, like my browser, example, my browser. So let's say Google Chrome. It's a Chrome browser. So we call that the client actually. So when you make the client actually makes a request, it creates a request to google.com, example. So that request will be sent to something we call uh, server, so Google server example. So basically client will request, hey, I want google.com, and the server will respond saying that, okay, here is the page. Something like that. So technically, if you go, they call this as a API request, let's say, which includes like URL example, whatever the URL is, and some data. That's a request. You also get the reply from the server. We can call API response. So something like again, API response also has some data, some cookies, whatever. Like it's all depends on the app. So these are the terminology I think you should know. The client, server, API, request, URL, payload data or data, let's say, response. So these are the terminology I would like you to just remember. Like, so for example, we have our own app. Let's say we have our platform dot. So you can see we have, so let me log off. So this is our app. I'll just remove this. Okay, this is our app, platform.teachandden.xyz. So if you go to inspect, like right click, inspect, you can see the action, everything. So let's say you go to network tab, you clean everything. Let's say I type something, example, whatever, random password, random thing. So when I click on sign me in, it will send a request, API request. So you can see that. Let me click. You can see, now see wrong credentials. This one, first one, yeah, this one. Yeah, you can see. This is the UI side, but this side, if you focus on, so there is a request is sent, something like this. This is the request URL. You can see, and there are some methods like get, post, put, delete. This is the post method. So maybe I'll tell you what that is. So maybe I'll just copy it. So something like that, like login page. There is a request URL, some URL, whatever the URL, HTTPS slash URL, no, whatever, like, it doesn't matter. And you can see payload. Payload means whatever the data that the request has. So request payload, let's call it request payload or API request. So there are different names, people call different things. It's most likely like a JSON object, like dictionary, like in Python we call. So key value pairs, something like this, something like this, something like that. Something like yeah, something like this. Key value pairs. So this is the request payload. So this is the request URL, this is the request payload. It will be sent to the server, and the server, obviously this is a login page. It will take all the details like email and password, and it checks that, hey, is that like password email right? If it is right, it replies something. If it is wrong, it replies something. You can see it replied saying that error equal true, or message equal like wrong credential, something here. That's exactly what you can see here. So this you can call like API reply, you know, response payload, let's say. It's different terminology. So request payload and response payload. Response payload, whatever the payload is. It could be wrong message, wrong credentials. It could be success credentials. It depends on the whatever they created. Like just copy, just something like this. This is also very much same as uh, key value paid format. Something like that. Similarly, I try to enter the right username. So let's write username cyber the rate. So enter the right username. I'll just clear this everything. I enter now. You can say I logged in. So many requests, but let's see one request. You can see this is a success, login success. You can see I equal false, login success, roll something student, and I got some token ID, something like that. So this is a successful login. But the process is same. Whether successful login, failed login, the idea is same. The client makes a request to the server. The server has a specific URL, a request URL, and the client, of course, sends some data, and the server checks the data and gives you the response. So technically, they call request payload, response payload, request URL. So all of these are technical terms. So this is how web app works. So the typical web app works like this. You have a client, server, DB, and API request and response. So that's how it works. Maybe you can see some application architecture. This is how typically like this. Your front end, I mean, the client could be anything actually. It's not necessarily a laptop. It could be mobile phone. It could be any other, device also. Like so, basically, you make a request to the server. The server can speak to the database, any database like Postgres database, local database, or NoSQL databases, cloud databases, or file systems. And based on the reply, the server will give the response to the client. So this is how any web application usually works. Yeah, something like that. I mean, this is general, very general idea. Of course, it depends on specific applications. People prefer different architecture, but the idea is very much same. You make a request, you get the reply. So that's they call API, like mostly like. So there are two layers or three layers: front end, back end, DB. Or client side, server side. So these are all terminologies like client side, server side, front end, back end, database. Like so, that is how web application typically works. Like a general web application, like mostly. If you look at any web application, the general idea is that only. Like so, usually the client, the front end is written in the idea of, for example, front end. Usually, we have front end technologies or tools. For example, people use HTML for CSS for styling, JavaScript for some, coding capabilities, or maybe React. So there is a React, Angular, PHP. So different languages, different technologies, tools are there to build the front end. To build the back end, you require a strong programming language. Like, let's say you can build a backend with Python, you can build a backend with Java, you can build, I mean, these two very popular, but you can build Node.js, is another popular backend. Yeah, etc., etc. You have even more like, and you have another thing, DB. So database, let's say a database could be different databases. It could be SQL databases, SQL based databases like MySQL or PostgreSQL, or it could be NoSQL databases, something like MongoDB. It could be some cloud databases. So yeah, it could be anything. So typically, a web application is created using a combination of these tools. Like front end is made by these tools, any of them, I mean, mix of them. Back end is made by one of them, databases, and the talk between front end and back end happens via APIs. So that's how you speak to front end and back end. The APIs they call. So you create a API and you make a request to backend from front end, and the backend will respond to front end via the API. So that is the foundational knowledge you need to know as a security guy. I mean, you need to know first what is web application. So then only you can think the security layer on top of it. Yeah, so that's the overview how web application typically works. Now let's try to understand the security aspect. What is the security and stuff like that. So as you can see, there are multiple components here. There is a component of front end, there is a component of back end, database, and API. From security standpoint, you should be able to think in all ways, which means you should be securing the front end. Make sure that, uh, so maybe I'll just write it down. Security risk, let's say. So let's say there is a front end security risk. So front end risks like, for example, somebody can, uh, what do you call? They can steal your browse. Maybe you can call cookies data or sessions data, something like that. They can monitor your session, or they can steal your inputs. So inputs means you enter like usernames, passwords, any kind of credentials you enter on the site from front end. They might take your those kind of credentials like most. So even SQL injection also is part of it, but SQL injection in a mix of backend also. Yeah, but it's front end you can have UI. So yeah, there could be some of them. There could be some of them front end risk mostly. Similarly, there are back end risks. Uh, so back end means server risk, server side attacks, like so mostly API they send the API requests, like fake requests. They can do some sort of like they call DOS and DDoS attacks, uh, more like a continually eating the with fake requests, like thousands of requests per second, overloading the server. So server will not be able to uh, will not respond to every request server. It's gonna slow down these things. Uh, and there are maybe you can, again, it depends on how the backend is designed. If you know exactly how the backend is designed, you can go into very specific you know ways. But there are backend risks, so they have front end risks, and there are of course you have database risks database risks, which more like somebody can steal your database. Somebody can steal your username, passwords of the database and try to, extract the data without, yeah, just a second. Yes. Yeah, so there are different types. There are API risks also. API risk means somebody, kind of sending, testing APIs and sending, some false data. So again, it depends on specific application, but you can see that the security is needed at every layer. Each layer, there needs to be a, there needs to be, some sort of security concept or future. So if one security is compromised, example, obviously it's not a good web application. So you need to think in all different ways, make sure to secure every way. So obviously one person cannot be able to do that. Maybe they might divide it into bunch of people, like, front end security, back end security, DB security, etc. But usually developers also should focus on security layer before they build any kind of front end or back end. So yeah, so that's the high level idea. Security risk. Maybe we can go into a very, very specific module, very specific testing tool. So there is a tool called Burp Soup. So we can see it, like, let's say Burp Soup. So Burp Suite, we have community edition, which is free, and we have the enterprise edition also for them. You can see it's a website web security testing. Like you can use this tool to test the web application. Security testing. You can do all sort of things. You have to download it. I already downloaded it, but if you want to download it, you just go to this website and download your operating system and just download the file and install it. Like, so I already installed it. It's already available on my MacBook, but if you want to install, just go to the I mean, you can Google it, get the right website and download the Bubs. Like, its community edition is free. Professional, for us, community edition is good enough for learning purpose. More purpose, maybe we need the professional one. I believe they provide free trial for professional, but let's see. You can see there are vulnerabilities. They are saying it like there is a cross-site scripting, there's SQL injection. You can see we already saw SQL injection, so you get some idea. You can test the same thing in Burp Suite also. Server-side request forgeries. So this is server-side attack. You can do all sort of things like using Burp Suite. Maybe I'll try to give you an idea. But first, let me enhance this.
I think recording has to resume also.
Yeah, just a second. It's not there.
Sure.
Oh, yeah, it's there.
Proceed.
Yeah, it's recording actually.
Right,
Yes,
okay, that's it.
yes. Yeah, so the threats come from many threats come from the client, threats come from the network also, like, for what maybe man in the middle attacks, like threats come from the backend API, database leaks, pipelines, even misconfigurations. Yeah, you have different types of threats. Like if you do, you can see typical front end threats, a bunch of them. Course, again, this all like very detailed. If you're a web application, I mean, if you're a front end developer, you understand this terminology. But I assume that you have some idea, not like complete idea of application. So we can see some of them. So there is a clickjacking, local storage misuse, cookies, insecure cookies, man in the middle, man in the browser. Like, so, and these are the backend again. Again, depends on the how the backend is designed. It isn't applicable for all, but it depends on the specific backend components. Injection attacks, example SQL, no SQL injection. You already familiar with it. Session management attacks, business logic flaws, something like that. Again. And the database attacks also is somehow similar, but like data leaks from logs, you know, uh, to log queries, slow queries, those like, different things are there. Network attacks also is possible. So usually network attacks, usually big guys will take it, mostly. And the operational attacks, like, again, it depends on the very specific application. So it's very, I mean, it's not a good idea to generalize all attacks are possible with one application. For example, if you look at our application, usually our application is designed like front end is React, back end is we use Python, we use serverless. Uh, you know, we cannot face any network problems because we use in a good cloud network. They will protect all the network issues. So we don't do any SQL injection attacks, no SQL injection attacks. That's fully taken care. Maybe we might have a problem with the idea of front end attacks. So because we know that front end is not fully like cool, so there might be some improvements to do on front end. So yeah, somebody can steal cookies, somebody can misuse our front end clause. So back end, I don't think we have any attacks. I mean, our back end is very solid. Like front end is little vulnerable, I see. But some of the things we did it on purpose, just to show you guys, I mean, security people, but they are not a major issues. They are very minor. Like, for example, you can see the password is very open, and that's on purpose. Yeah, some are purpose, but some are maybe not. So it depends. Anyway, first let's go to the burp suit. Right. So yeah, this is the burp suit. I'll just click next. It's temporary. Start burps. It's a community edition. Yeah, you can download free. Your machine, no need any other, Kali Linux or anything. But it can run on anything. Yes. Yeah, this is how it looks like. First, I'll give you overview of the burp suite. For example, you can see there are a bunch of tabs like target tab, proxy tab, intruder, repeater, of these. Most of the time we use like, for example, intruder is for attacking. Repeater is for mostly testing one by one. Collaborator, I don't think community supports. Collaborator is mostly professional only, so we cannot talk here. Sequencer also sometimes we might do. Decoder is very simple to decode the text, but most of the time you use target, intruder, repeater. Proxy is obviously there. Proxy. Mostly these four tabs. Dashboard is more like an high level dashboard of all of the tasks. Target, proxy, intruder, repeater. So these four tabs mostly will do a lot of work. The rest of the tabs, you know, it's light only. It's not that big a deal at this time. So I'll tell you how burp suit works, what burp suit is. So then we can go look at some of the use cases that we can do in burp suit. So as we spoke already here, client request to server, you get the response back. So I copy this. Burp suit, what burp suit does is burp suit acts as a middle person, like we call proxy. So there is a client sends a request. So that request does not go directly to the server. That request go to the proxy, which is where burp suit is, like a middleman, like that. So we will reduce it. Okay. Now the burp suit will send that request to the server. So anyway, I'll reduce these also. Something like this. Something like this. Yeah. So usually in the past, we saw that client directly sends a request to the server, you get the response. But the way burp suit works is burp suit works as a proxy. Proxy means middleman. Burp suit sits between client and sender. Each request the client sends to server, it goes via burp suit. Similarly, the server also same. The response you get the server, the response first comes to the burp suit and then client. So in this way, the burp suit can let's say can monitor what's going on between each request and response. The burp suit knows everything, like they can track, monitor. So for example, client sends a message, hey, I want this. So it will be stored in the burp suit. Hey, client asked this. The server will respond back like, hey, take this. The burp suit will kind of stores that information. So in a way, the burp suit used to monitor, to check what's going on for each request uh, between the client and server. So that's one of the use cases like of the burp suit. So we'll see it. So let's go to burp suit. So that's one of the use cases. Maybe another use case also I'll tell. Just a second. So meanwhile, I'll just give you more context. Yeah. So this is one intercepting proxy or traffic between client and server reply. That is the main point. Reply.